Yeah, so in 2020, I was working at a company called Data Robot. Anyone here at Data Robot? Go to their website. They just rebranded their entire website and got rid of the robot in their logo, which seems like a crazy thing to me. But anyway, I just found out about this. I'm a little shook. But anyway, I was working for a Data Robot in 2020 for the US government. We were working with Health and Human Services to forecast the spread of COVID during the pandemic. Because it turns out that one of the things that's really helpful when you're running a vaccine trial, like Moderna's and J&J's and so on, is to be able to forecast where the hotspots are going to be, because that's where you want to recruit patients from, so you can finish your vaccine trials first. And I had the privilege of working with the government to help accelerate those vaccine trials by pointing them in the right direction to recruit people for the trials. We think we shaved 6 to 8 weeks off of the vaccine trial development stuff by just targeting the hotspots, which was great. The crazy part is we couldn't actually use Data Robot for it at all. We had to code it all from scratch. And that's the big downfall of these low-code, no-code tools, is that they don't really extend to real problems. And so I think everybody's pretty well figured out that low-code, no-code, the emperor's got no clothes on that one. And so Zerve, I joined Zerve. I helped found Zerve with the other 2 co-founders based in Ireland to build the tool that we needed. And so we're going to have a look at it today. I built a little RAG workflow to basically scrape all the information off of a website and then build a little chatbot to answer questions about what was on that website. So is everyone familiar with RAG? It's a stupid name. This guy, Peter Lewis, he's a British AI researcher, named it. I actually read a quote of his. He said that if they'd known they were going to get famous for inventing RAG, that they would have thought about the name for longer. But basically, it's a very simple concept, and that is that LLMs are trained on huge amounts of data, but none of it's super, super specific. So if you have data that was maybe not included in the training set or has changed since the models were actually trained, then the models are likely not going to give you very good answers when you ask them questions about those topics. So what RAG is saying, okay, I'm going to take my initial prompt that my user provides, and I'm going to query some database. I'm going to query Yugabyte to get some additional data to enhance that prompt so that I get a better result. Right? It's super simple. It's a very, very simple concept. And so that's what I did. We ended up going with Yugabyte. We're super impressed with Yugabyte. Just the stability and the scalability, it's been great with many of the customers that we work with. And so I used it in this application. We're using the managed service. It's great. It's in the cloud. And so that's been a super solid part of the application. We're also utilizing AWS Bedrock. So you guys know Bedrock? It's AWS's managed LLM solution. Which is also great. It's makes it super simple to query these. Of course, you don't have to use Bedrock. I mean, Hugging Face has tons and tons of models that are out there that are open source and everything. So, but we use Bedrock for this. We have a pretty tight integration with Bedrock built into Zerve. And then why Zerve? Apart from the fact that that's our company, we are a code-first development application that was actually built for data scientists, which is kind of crazy the way the tools in the data science and AI space work. They were all built for other people. Like notebooks were built for academics to use as classroom scratch pads. And IDEs like VS Code was built for software developers, so they're terrible for data exploration and stuff like that. So we're trying to build a tool that gives you all of the benefits of a notebook without any of the stability problems that you would normally experience, so that you can actually deploy these things. So here's the website that we ended up scraping. It's ESAL. Actually, I can go here. Doop. There we go. And it's a website about getting people in engineering fields involved in like civic organizations. But what they do have is loads and loads of articles that I wanted to use as source material for this little application that we were that we built. So you can see there's lots and lots of them here. And so I wanted to go and scrape them all off. And so I thought that I would just give you a little demo of kind of how we did that in this little application. So this is Zerve. And Zerve is node-based, so your code is laid out in a DAG, a directed graph. The code runs from left to right. And so we've got different layers over here. So this layer of code is it's actually a scheduled job. And in this scheduled job, we're basically going out and we are scraping all of those articles off of the website and then storing them in a database, a Yugabyte database. And there's a couple of really cool things going on here. One of them is the fleet. So we do this really interesting thing with scalability. So rather than go in series and query every page and grab every article and scrape off every bit of text one at a time, we use this thing that we invented called the fleet, where we're actually, we take a list and we are spinning up serverless compute to distribute that compute without any, you don't have to guide it. Like you don't have to write code for it or anything like that. You just use this spread function to do it and you say, okay, and then you get 20 concurrent runs. So I'm doing all 20 pages of articles all on different servers that are spun up serverlessly using Lambdas on AWS. And so each one I can see kind of what's coming back on those servers. So you can see the scalability of that. You can just pass it a list and have it parallelize across many different sets of servers. Whereas, if you were doing it in series, it might take forever, or you might have to spin up some, Dask cluster or write multi-processing code and manage a pool of workers and all that kind of stuff. You don't have to do that here because of the way we operate serverlessly. So here's the start of it. So I just asked a really basic question. What is ESAL's position on water conservation? And the naive prompt here, I'm connecting to Bedrock here. I can pick any of the models that are out in Bedrock. I happen to pick the latest Claude, so Claude 3.5 Sonnet. But you can pick any of them. And it actually says, it apologizes. Sorry, I don't know what ESAL is. I can't help you. So we're definitely going to need some additional firepower to get going there. And so that's one path, just going from the initial prompt to the actual results. But I'm also coming down here to a RAG pipeline. And so I'm querying Yugabyte to pick up some data, and I'm combining it with this question to make, to actually do two steps. So here I'm saying, go ahead and search through all of the articles text that we have and pick the top 3 that seem the most interesting, and then return me the titles. So that's what this guy does. He's going and I'm here sending it the prompt, and it gives me the 3 most interesting articles based on what came out. And then I'm taking those 3 articles and I'm appending them to my prompt. So I'm sending it the original question, and then I'm sending it all the text along with it. And so then I get to my final prompt, and here we go. We can see, based on the provided information, here's what it thinks. So this is my development layer. So this is how we have it set up in Zerve in different layers. And so you can see I took a model that knew nothing about ESAL, and by querying the database and pulling in some additional data, I was able to get a really good, reliable answer about what's really going on here. And so I took this article text and I put it into a scheduled job so that this thing can run on a regular basis, because they add articles all the time. And so I want to be kept up to date. And so this runs on a recurring basis. It's next set up to run on the 17th of November, which is Monday, I think. It runs at 5 a.m. And so this executes and stores the data for me, and just like I want. But then I wanted to build an API, which is really outside the skill set of a lot of data scientists these days. I mean, a lot of machine learning engineers can do it, but typically, if you're a data scientist on a data science team, you don't have what you need in order to build an API, right? Whether it's access to cloud resources or whatever it might be, the capability of actually writing that API out, you need an engineer, and so you end up with all these bottlenecks and dependencies between teams, and it ends up making everything take a lot longer. But in Zerve, we've got an API builder that is actually really convenient. So what I've got here is I've just set up this API, and so I've given it a name, so you can see the URL here. It's an API key. You can set up security, specify how much memory you need, all that kind of stuff. And then you can add as many roots as you want. So if I wanted another root, I would just drag it down here. And then I could add maybe a get root or something like that. But I don't need that in this case. So here's my root. I called it rag, so it's /rag. And then I can go in here and I can tell it what to expect as far as what your payload is going to look like. So it does data validation for you. And then I can give it like a test phrase, that sort of thing for actual testing. And then I just do that. I go in and query Yugabyte again, get this, and it's the same workflow as before, only I'm returning the output. So once I click deploy, whoops, that got it. There it is. Once I click deploy, then I can get logs to see how all that worked. I can download all the source code, download a Docker container with all the dependencies and the Kubernetes setup files and documentation and all that kind of stuff. And that all just happens automatically. When you deploy it in Zerve, then it's hosted in this case, AWS, using Lambdas, so it scales and all that kind of thing. But like I said, most people, or many people anyway, have their own sort of deployment pipelines already, so they don't want to deploy in Zerve for some circumstances, so they might want to just download the Docker container and go to town that way. So there you go. So, this is a simple curl request, and then there you go. There's the answer. So we took, and with a relatively small amount of work, started out just sort of exploring a bit, and trying to get this thing to work, and made it into an application that's actually live and hosted and running and scalable and available and all that kind of thing in a relatively easy and short period of time. A couple of other things I suppose you could do. We looked into doing like a vector database with this and vectorizing the articles and doing some sort of a matching there. That's another conceivable possibility. It's pretty easy to vectorize these things now. And since article text is relatively unstructured, that might be a natural kind of next step to do. It would also give you the ability to use things like images or audio files or something along those lines. So that might be another interesting next step. Let me point out a couple of other things. The first is dependency management. So it turns out that it's really important to be able to set up these environments. If anybody's ever had to onboard a new employee, getting their laptop set up properly with the right packages installed and the right versions, and oh, by the way, we use NumPy 0.17 here instead of 0.23, and so on and so on, managing virtual environments and all that craziness in order to make that work. The nice thing about Zerve is that we handle all of the dependency management for you, and you can have multiple people logged into the same project all at the same time. So like if you were in here, I'd be able to see your mouse moving around. I'd be able to see the code that you're writing. It's very Google Docs-like experience so that you can actually collaborate in a real way. And the other thing that's really interesting about the collaboration is that I can have multiple languages going on at the same time. So if I want to have somebody writing SQL up here, they can write SQL and they can connect it right to these Python blocks. If somebody's in R, they can work in R. And because of the way we handle the data, it's completely interoperable. So you can SQL query a pandas data frame. You could write ggplot code in R to visualize some Python data structure. And that's by virtue of the way we set up the architecture. See, each one of these blocks runs its own kernel. And so they're all independent. They all run serverlessly. But each block caches, serializes, and stores its data on disk so that all of the artifacts of the analysis get preserved so that you can access them from elsewhere. But that also means in that serialization process, we learn something about it. And so that's where the language interoperability comes from. So we serialize data frames as Parquet files. And so R knows how to deal with Parquet. And so suddenly you can use R on Python and Python on R and SQL on Python and all those combinations there so that you can have a full team of people all working in the same place, all in the same code without having to email notebook files or move from RStudio or Posit or whatever they're calling it these days to Jupyter, back to VS Code, into Spider or whatever it is. And then the last thing I'll show is just we do integrate with things like GitHub. So I can make commits, and each of these blocks would be represented by a file on GitHub, so that we can you can track everything and see what's going on and interact with the data outside of Zerve and so on. So that's it. That is the application that we built. Just a very simple kind of almost a toy example, but you can imagine it scaling in a pretty significant way. One of our first customers was Canal Plus, which is like, anybody know Canal Plus? It's like the Netflix of Europe. It's a big, big media company in Europe. They did something really similar with a recommendation system for movies. So like you go on and type, give me sports comeback movies, and they'll come back and say, hey, you should really watch Rocky or something like that. Something like that has to be scalable, has to be big, has to be super reliable. And so that's why tools like Yugabyte and Zerve and AWS Bedrock are really great for applications like that. So with that, I'll pause, and I think I have about 5 minutes left for questions, if there are any. Oh. Yep. Right. Yep, it's just text. Yeah, so the question was, did I vectorize the articles before I stored them? We certainly could have done that, but in this case, I just passed the article text as it is to an LLM in order to feed it that information. So I didn't have to vectorize it or compare. If you did vectorize it, then you'd end up vectorizing the prompt as well, and then doing something like cosine similarity to compare, which you wouldn't have to do if you were using like a Weaviate or some vector database that was sort of built for something like that. But yeah, in this case, I didn't do it. I just made 2 steps. I passed the titles to an LLM to pick which ones were most relevant, and then I passed the text of the articles to another LLM in order to teach it what it needed to know to answer the question.
Folks? Yeah. Awesome. So to extend onto that question, could Zerve potentially use like PG Vector on top of Postgres?
Louder?
PG Vector, like
sure.
within Postgres?
Yeah.
So it could just add a box currently? Nice.
Yeah.
Okay. So you could just add a step to vectorize that through any model that you're using, store it in PG Vector, and then later bring it up. Okay, cool.
Yeah. Awesome. Yeah, at the end of the day, it's a coding environment. So whatever you can do in code, you could do here. So.
Any other questions?
All right, awesome. Well, stop by Zerve.ai and sign up for a free trial.
Thank you, Greg.
All right, thanks.
Hold on, one question. We have a question? Okay, sorry.
Okay, all right. You're hiding over behind the
Questions
projector.
are always good. Yeah.
No, I just thought it was really impressive how you have the ability to connect down into GitHub and integrate it into a nice, easy to read workflow, right? I was just curious as far as, components that you may be able to connect to, obviously in Bedrock. Have you looked at any software branches, not just for retrieval, but also for curation, guardrails, that sort of thing, as it relates to data curation?
I see. So we've done a fair number of integrations. So like with weights and biases for like experiment tracking, but we're open to all kinds of new things. So it might be a good thing to explore.
Thank you.
Yeah.